vagus nerve, highlighted in green here, gives off several branches in the cervical region. The first is the pharyngeal branch, highlighted here in blue. The pharyngeal branch is responsible for motor constriction of the pharynx. A lesion here would result in dysphagia. Next is the superior laryngeal nerve, highlighted here in pink. It divides into two terminal branches. A lesion to the superior laryngeal nerve would result in a voice that is weak and tires easily. The first branch is the internal laryngeal, highlighted in orange, and supplies sensory fibers to the superior surface of the vocal cords. The second is the external laryngeal nerve, highlighted in purple. It's a motor nerve that descends posteriorly to supply the inferior constrictor muscle of the pharynx and the cricothyroid muscle, the lone intrinsic laryngeal muscle not innervated by the recurrent laryngeal nerve. Lastly, we have the recurrent laryngeal, highlighted in purple. It innervates the intrinsic laryngeal muscles except for the cricothyroid muscle. The intrinsic laryngeal muscles control the shape of the rima glottis and the length and tension of the vocal folds to produce sound. A unilateral lesion would result in paralysis of the vocal folds, leading to hoarseness and dysphonia. A bilateral lesion would result in aphonia and inspiratory stridor. Next is the hypoglossal nerve, outlined here in pink. It originates as several rootlets in the medulla, exits the cranium via the hypoglossal canal, picks up a hitchhiker that is the superior root of the ansa cervicalis, highlighted in blue. It then passes anteriorly as it innervates the muscles of the tongue. A unilateral lesion would result in ipsilateral paralysis, where the tongue would deviate towards the paralyzed side. Of note, in this image we see the vagus nerve, highlighted here in green, and we can see that it runs lateral to the internal carotid artery and medial to the internal jugular vein. Lastly, we have spinal accessory nerve, highlighted here in purple. It originates from the rootlets of the first 5 cervical segments of the spinal cord. It carpools with the vagus nerve as it descends through the jugular foramen and into the neck. Here, it runs along the carotid artery as it innervates the sternocleidomastoid. It then crosses the occipital triangle, continues to the anterior border of the trapezius muscle. Innervation of the sternocleidomastoid allows for neck rotation, and innervation of the trapezius allows for shoulder elevation. A unilateral lesion would produce weakness in the sternocleidomastoid and reduced neck rotation to the opposite side. Additionally, you would expect weakness and atrophy of the trapezius muscle, resulting in the inability to elevate the shoulder.